When will a fraction result in a recurring decimal? When will a fraction result in a recurring decimal? Recurring decimal. Recurring decimal. What do you mean by recurring decimal? After decimal, digits gets repeated. After decimal, digit gets repeated. After dot, there will be certain section of digits that will get repeated. Henceforth, the name recurring decimal. Otherwise, the name will be non-recurring decimal. When will it happen? Listen carefully, sir. A fraction will have a numerator. A fraction will have a numerator and a denominator. A fraction will have a numerator as well as a denominator. If the denominator is not taking any powers of 2 or 5 or combinations of 2 and 5, a and b are whole numbers, then I will get a recurring decimal. Then I will get a recurring decimal. Then I will get a recurring decimal. When the denominator is not taking any powers of 2 and 5, when denominator is not taking any powers of 2 and 5, then I will get a recurring decimal. This is where the teachers will end the concept. When it is not taking 2 and 5, it can take a prime number, it can take a power of a prime number, it can take powers of a prime number. Like that, so many cases will happen. All that cases we will do. A fraction will have a numerator and denominator. Denominator, if it is not take any power of 2 and 5, then I will get a recurring decimal. Listen carefully. Case number 1. Case number 1. Multiple cases which we will do. Denominator is a prime number. Denominator, it is a prime number. Case number 2. Denominator, it is prime number power k. P1, it is a prime number. P1, it is a prime number. Case number 3. Case number 3. Denominator, it is a power of a prime number. P1 power k1 into P2 power k2. P1, P2 are prime numbers. P1, P2 are prime numbers. Every composite number can be written as a power of prime basis. 2 and 5 will result in a terminating decimal. Other than 2 and 5, what are all the other numbers? Either it can have a prime number. If it is a composite number, for example 12, I can write it as 2 square into 3, or it can be a square of a prime number 9, 25, 49 and so on. So you take any number that comes into your mind. 20 will come in 2 square into 5, case number 3. 42 will come in 2 into 3 into 7. Okay, the next one 25 will come in 5 square case. 37 it is a prime number. This will come in case number 1. Other than 2 and 5, any other number. These are only the 3 cases that are possible. These are the only cases that are possible. Now listen carefully. If the denominator, it is a prime number. Denominator, it is a prime number. What I will get? I will get a recurring decimal. I will get a recurring decimal. Recurring decimal. Now, recurring means repetition. Maximum number of digits. Maximum number of digits repeated. Maximum number of digits repeated in a block. Repeated after decimal. Maximum number of digits repeated after decimal will be P minus 1. This is a very famous Fermat's little theorem. If the denominator, it is a prime number, maximum number of digits it will get repeated after decimal will be P minus 1. P minus 1. For example, 1 by 7 is given by 0.142857. 142857. See, after decimal, the maximum number of times digits that are getting repeated in a block is 7 minus 16. It can be less than, but it can never be greater than P minus 1. It can never be greater than P minus 1. This is how many digits will get repeated after decimal. Maximum number of digits that get repeated after decimal will be P minus 1. If it is P1 power K, denominator it is P1 power K. The same concept. Maximum number of digits that get repeated is P1 power K into 1 minus 1 by P1. P1 power K into 1 minus 1 by P1. P1 power K into 1 minus 1 by P1. These very beautifully explained in the book Higher Algebra by Hall and Knight, and all these conclusions are based on Fermat's little theorem. If it is like this, for P1 power K, I will get P1 power K into 1 minus 1 by P1. P2 power K, I will get P2 power K into 1 minus 1 by P2. Take the LCM. Take the LCM of these two. What it will give you? This concept. Maximum number of digits repeated after decimal. Maximum number of digits that are getting repeated after decimal. Very, very important. Because you do not know this concept, you might consider this concept as very difficult. For example, see here. For example, if I take 1 by 49. 1 by 49. What will be the answer? 1 by 49. Maximum number of digits repeated after decimal. This is the concept that we are doing. Maximum number of digits repeated after decimal. Maximum number of digits repeated after decimal. 49. 49 is of the form 7 square. So, out of 49 how you got this one? How you got these P1 power K into 1 minus P1? If I take 49 consecutive numbers from 1 to 49, for every 7 numbers, 1 number is divisible. So, remaining 6 numbers are not divisible. So, 49 into 6 by 7. Answer is 42. Maximum number of digits repeated after decimal for 1 by 49 it is 42. After dot, the maximum that block, it is a recurring decimal. Recurring decimal means digits gets repeated. Digits gets repeated. After dot, how many digits it will get repeated? For example, if it is 1 by 63. 1 by 63 will be 1 by 3 square into 7. Are you all with me? 3 square. For every 9 consecutive number, 9 numbers. 9 is composite number. For every 3 consecutive, 1 number it is divisible. 2 by 3 are not divisible. So 9 into 2 by 3. This is 6. Here also it is 7 is a prime number 6. LCM of 6 and 6. Maximum number of digits repeated, it will be 6. Idea it is clear. You take any number that comes into your mind, you will be able to solve this question very, very fast. Very, very fast. Suppose for example, if I take 1 by 5 cube into 7 square, maximum number of digits repeated after decimal. What it will be answer? 1 by, let us take 3 cube into 7. 3 other than 2 and 5, right? So 3 cube into 7 square. So first write down the composite number. For every 3 consecutive, 1 number divisible. 2 by 3 numbers are not divisible. 27 into 2 by 3. This is 18. 49 I got 42. So LCM of 18 comma 42. So this will be LCM of 18 can be written as 6 into 3, 6 into 7. 6 is taken out. 7 3s are 21. Maximum number of digits repeated after decimal will be 126. Maximum number of digits repeated after decimal will be 26. I hope the idea it is very, very clear to you.